I want to keep them going weekly if they remain productive. But we could go to bi-weekly. I was actually not going to do one this week. And then Alan approached me about giving a presentation, so I figured let's do it. Week one, we talked a little bit about censorship, about YouTube. I talked about materialism and versus the Æther framework, and I kind of related that to prayer and vibrations and how Æther kind of changes the paradigm, because if prayer is a vibration, then I'm sorry, I'm kind of going off on a tangent. I mentioned that we talked about the fracture in the community, about the Æther that's going on, and kind of how we don't want to focus too much on that. Instead, we just want to talk and learn. The conversation's evolving, and some people just don't seem to want to evolve with it. Earth is stationary in relation to the Æther wind, and measurements have shown this. The theory of relativity is like bad code. It has to use new concepts to address the problems instead of fixing the problems themselves. There's a lot of problems with black holes. They rely on abstract math. And then we talked briefly about fiber optics and the speed of light. So that was week one. And then last week, week two, we watched a video about interferometers and how they work. We talked about how Wang used fiber optics to show linear segments contribute to interference fringes. The Miller experiments found varying light speeds at different altitudes, challenging relativity. And then also we talked, of course, about the relation of the analemma in those. And then Alan gave a fantastic presentation about the Æther framework. Reinhardt Æther theory suggests a universal Æther, mathematically similar to special relativity, but more uniform. The Æther framework proposes a universal Æther medium for electromagnetic radiation. So I also ran both meetings through the AI for a to-do list. It gave us like 30 action items from both of them, and they were all very broad. Learn about this, explore this. So I managed to pull out 5 kind of concrete to-dos from there, some of which are very difficult for us to do at this point, but they're things that we can start exploring. The first of which is using interferometry to gather Earth and Æther drift data ourselves. We can also work on learning about the Æther wind's effects on electromagnetic waves. We can work on describing electromagnetic waves' relationship with the Æther, which is kind of similar to the previous step there. And then we can build systems, keep improving on building our systems for sharing information, and work on ways to overcome censorship from tech companies. So that's where we currently stand here. I'm like super glad we've been doing this weekly. I hope we can keep doing it weekly. And yeah. So Alan, I don't know if you want to just jump right into it. I'm cool with that or whatever, unless Shane, if you want to say anything or whatever.
No, I got nothing. I was just going to come and watch Alan's presentation. Unless anyone else has stuff. What's up, Jackie? Thanks for coming as always.
Hola. Hello, guys.
You're welcome. Yeah, give me 1 second. Okay. Get there in. Thank you. Thanks. All right. Sorry about that. All right. Yeah, so there was a hot topic going on right now about Michelson-Morley and whether or not it's an experiment. What is an experiment? What is science? What's natural science? What is the Æther? What is a framework? Those sorts of things. So I wanted to make the case for Michelson-Morley being an experiment, and I wanted to go over the basic fundamentals just so we can kind of agree on what is science. Remember growing up, we were all taught that there was a hypothesis, an experiment, and thoughts were formulated based on experimental evidence and all that sort of stuff. So just kind of wanted to touch on the basic fundamentals of that, and then establishing some sort of framework that we can agree upon that, examine the Michelson-Morley experiment, and and go over what exactly makes it an experiment versus a parlor trick or something that's not repeatable or something like that. So I'll go ahead and start screen sharing. I totally forgot to do that. So let's see here. Should be good to go now. Sorry about that.
There we go. I got you.
All right. Did it share okay?
Yep.
All right, cool. Is it full screen? All right.
Yep.
Okay, so Michelson-Morley experiment. Experiment, demonstration, or parlor trick? The scientific method,
Are
what it
you
is.
are you switching it back and forth to full
Yeah.
screen?
Yeah.
Oh, okay.
Do I need
All
to change the? Yeah, hold on one sec. I need to
Well,
change
no,
the
because
way.
at one time I kept switching back erroneously, and we watched it for like 10 minutes before someone said something. We were like, "Oh yeah, no, not supposed to do that."
Yeah, 1 second, dog. I got you. I'm just gonna share my whole monitor. How's that?
Yeah, that's how you do it. Yep,
All right.
for PowerPoint full screen.
Yeah, there's one segment at the end for audio, but we'll sort that out when it comes. Okay, so moving on. The scientific method, what it is and what it is not. So it's not a formula, and it's not a magic explanation for things. Um, it should be based on reputable observations and experiments. Basically, that's the summary here, and this is taken from I forget the university, but some university.edu. I got the website here, and they just kind of went over like what is the scientific method and what are the steps of an experiment and all that. So I thought that would be a good baseline to go off of. So here they define some terminology. So hypothesis, theory, and falsifiable and null hypothesis. So it's important to for everyone to be on the same page. So we should sort out the terminology here. So a hypothesis, a statement that is made by a researcher that is a working assumption, uh, or that is a working assumption to be tested and proven. It is something to be considered true for the purpose of investigation. Example, the Earth is round. Now, obviously, they took that one a little far, but that's just an example here. So, a theory, general principles drawn from facts that explain the observation and can be used to predict new events. For example, Newton's gravitational theory and Einstein's theory of relativity, each based on falsifiable hypothesis and phenomenon that we observe. According to them, right? So falsifiable and null hypotheses. To prove false, a hypothesis must be or a hypothesis that is generated must be able to be tested, and it is to be either accepted or rejected. Scientists make hypotheses that they want to disprove in order that they may prove it to be a working assumption describing the event or phenomenon. So remember, they're not trying to like figure out what's true. They're trying to narrow things down and get as close as they can to an accurate description of reality or to whatever it is that they're experimenting with, right? Like that's the overall goal, right? And then to falsify what you think, how it works, right? And see if you can punch holes in it. And if you can't, well then, it sounds like you got a steady framework to move forward, right? So so this is done by declaring the falsifiable parts in the hypothesis, which we'll go over here later. And all right. So next step, next page. So the processes of the scientific method, right? So step 1, make an observation, gather and assimilate information about a phenomenon or process. Step 2, define a problem, ask a question about the observation that's relevant and testable, and define a null hypothesis so that you can, falsify your assumptions and all that. Step 3, form a hypothesis. Step 4, conduct an experiment. And step 5, derive a theory based on the outcome of the experiment and the experimental data and all that, right? Pretty straightforward. If everyone kind of remembers that as a kid, that's kind of how I remember it, have an observable phenomenon, ask a question, hypothesis, experiment, derive your theory, right? All right, now an important step here is replication. And this is that people should be able to take your experimental results and reproduce them themselves under, the same conditions and or varying conditions. So, that's a huge step to the scientific method is the reproducibility, right? That's very important in distinguishing something from like, hey, this worked one time. We can't really explain it. It's really interesting. There was a bunch of factors we don't know. But it's like when you have other people, really narrowing it down, that's where you get into, actual science being done and figuring out the actual underlying mechanisms of the phenomenon rather than just, eloquent ways to describe it with abstract mathematics. and filling in the blank with whatever variables you need to make it work. All right. So what we have here for the observation, we have step 1. Throughout the course of a year, the stars we see in the night sky change every 6 months. Is the Earth in motion with the celestial bodies, or is the Earth at rest with respect to the celestial bodies? So classic geocentrism versus heliocentrism. You know, who came first? Who's the how do we know which one's accurate? Defining the problem. Is the sky moving, or are we moving with the sky? From our terrestrial perspective and models based solely on observations, i.e. calculative models based on reoccurring cycles, there's no way to differentiate between the correctness of the axioms of heliocentrism or the axioms of geocentrism with respect to the rotation of the sky. Meaning that heliocentrism's core axioms for Earth is that the Earth is in motion and that it's rotating. And for geocentrism, the Earth would be stationary with respect to the entire universe rotating around us, right? And then, you know, other such axioms and principles like the Copernican principle, where there's no significance, there's no center. So these all axioms would be, how do we differentiate? Because if we're just looking at things in the sky, right, we can explain it based on a sun moving. So if you're on the Earth and it's moving and it's a rotating ball and all that chasing the sun, if you're looking in this direction at this time of the year, and then 6 months later, when the Earth has gone around the sun, you know, in the model, you'll see a different set of stars. So they have explanations for both situations. So for the geocentric, they have their circular and or elliptical and or geodesic orbits, depending on who you're talking to, right? So they have a wide variety to choose from on how the celestial bodies move in relation to one another. Now, for the geocentric orbits, you get into these really awesome paths here, and a lot of them seem to follow like a natural magnetic flux, which I'll showcase later. But right now, we'll just look at some geocentric models and the different ways that you could explain the phenomenon in the sky from our terrestrial perspective. So we have the Tycho model and Kepler's model. So you see these patterns here, and that's kind of what we'll get into at the close here. This is just some eye candy to look at for the orbits and the explanations for what's going on in the sky. So here we have a video I'm going to reshare with the audio so we can, actually, I don't think this even requires audio. So this is just this is just a magnet hologram, and you'll see some of the same patterns as the celestial bodies that that they can be, taking. So this is just a natural, natural patterns that are produced in nature, and So just in just in terms of mechanisms for an orbit or how things move in the sky, right? It could be following some sort of magnetic path. I think, what is this? This is every point of what was that?
Every sun, right?
Every latitude. Yeah, an observer at every latitude observing the sun mapped out makes this hyperbola here, right? Is that's what that is, right, Shane?
Yep, that's exactly for magnetic flat Earth when they did their crazy modeling.
Yeah. All right, so we'll go ahead. Yeah, so just more crazy magnetic stuff. All looks very similar. And then we got one more. So again, if you look at the orbits from a geocentric perspective, this is kind of the path that they'll be taking. So in order to explain things like retrograde motion and all that sort of stuff, that's where you'll get these motions where it's coming in and out. And that's the geocentric explanation for it. Or one way to explain it, rather. There's multiple ways you can explain it from a geocentric perspective, but that's how they came to do it. and it all follows, natural magnetic patterns. So with all that being said, let me get back to full screen here. Slideshow. All right. So just again, sorry, go ahead.
Would that mean that they would be producing the magnetic field themselves, like by doing their elliptical, by the way that they.
So whatever they're being projected on would be following that. It would be following that line.
Right, it makes more sense that they'd follow like the natural magnetic flux lines of Earth, and that's why he started with the ferrocell to show you what the magnetic field lines look underneath there, which aren't usually visible. And then if you take that concept to like the planet's path over the flat Earth, it's funny because they make the exact same like motions in the same pattern. I think that's what he's trying to show.
Yeah, and if you, I'm sorry, go ahead, Jackie.
No, I got it. I was trying to. Yeah, my brain didn't connect it for a minute. I got it now.
Oh, you're good. No problem. Okay. So, yep, just one more time. That's just a reiteration of that. I think that's the last slide for that. So to move on with the hypothesis here. So with all those models and different ways to describe the phenomenon in the sky, let's formulate an experiment here on how and what we can do to differentiate between these two models. So for the hypothesis, we have if heliocentrism were true, based on the yearly cycles, the Earth is required to be in motion at a certain speed, a speed of 30 kilometers a second to be precise. In combination with that, the current electromagnetic theory based on a stationary ether that carries the charge potential for an accelerating electric field to generate a magnetic field, which is to say the background medium that carries that charge potential for the electric and magnetic field induction, will also affect electromagnetic propagation in the form of resistance to the speed of light if you're in motion relative to that ether. So with that understanding of the rate of induction from Maxwell's equation and the etheric framework to provide the mechanism for the variance of C, Earth's orbital velocity should be revealed in the form of a fringe shift pattern. The variance in C should produce a fringe shift corresponding to the amount of resistance that the ether would have on the light beam that's perpendicular to the direction of Earth's motion around the sun at 30 kilometers a second. So imagine you're driving a car down the highway and you stick your arm out the car window and your arm is experiencing air resistance relative to how fast you're traveling through it. It's a very similar concept for the ether and the light beam. So if the Earth's in motion and there's that resistance, the light beam speed in which the propagation is happening will be affected by that. So we have some nulls, affirmations, and nulls here. So for heliocentrism, an affirmation of the theory would be 5 fringe shifts, and each fringe shift will correspond to 5 kilometers a second. So if they get a 5 fringe shift reading, then they got their 30 kilometers a second, and that's a successful, or that's positive evidence for heliocentrism.
Is there any actual relationship between those two things? Did you ever find that out?
What's that?
Like, is there any physical relationship to a fringe shift pattern to how far it would pattern? Or did they just make up that whole scale?
Yeah, it's just inferred.
Oh,
yeah,
right. Because they're measuring a motion and they're saying, okay, a part of that motion equals this many ticks on with this manufactured thing. And they're like, okay, we measured this many ticks. All right.
No, that's just the scale that they made up. No, the only thing that it ever corresponds to is sidereal time. So when they fitted it in within a 360-degree, 1,000-mile per hour relative to the latitude rotation, that's the only sort of translational speed that roughly fits. But other than so for heliocentrism, a null result would be no fringe shift pattern, so they're not able to detect any sort of motion. And falsified would be a slight fringe shift pattern, and we'll get into what that means with stationary with respect to an ether wind. And then for geocentrism, there's for affirmation that there would be a slight fringe shift pattern, so that would be ether wind with respect to a stationary Earth. A null result would be no fringe, meaning that the speed of light is invariant and there's no way to use it to determine motion in this test. And let's see. And falsified would be if there's five fringes produced, because that would provide direct positive evidence for heliocentrism. And for the ether theory, affirmation would be slight fringes and being able to reproduce these fringes, right? And making sure that they're outside of the air tolerance. So for the null, that would be, like I said, making sure that they're repeatable and outside of the air tolerance of the device. And then falsified would be no fringe, meaning that the speed of light does not change, so that there's no underlying mechanism to cause such variance. So with all that being said, and this is all setting up for the Michelson-Morley experiment, right? So this is what this experiment was all about. The way that it's framed in modern day is that it was an ether test, and it was to test, the ether and all this stuff. It was a twofold test. It was to test the Earth's motion, and it was also to test the ether. There are multiple ether theories. There's an ether wind theory. There's a stationary ether, et cetera, et cetera. Now, the way that they interpret the ether is obviously going to be relative to how they're trying to interpret the effects based on an Earth that may or may not be rotating. So you can see where they diverged from an ether wind to a stationary ether and all that, because they were trying to, equate these effects with respect to Earth rotation. But just, keep that in mind, because you'll often, if you look it up, you'll see like it disproved a stationary ether and there's an ether wind. It's like, how many ethers? Like, what's your favorite flavor? Like, it's all good, There's all the famous physicists and mathematicians and stuff that worked on this stuff back in the day all had varying theories to explain varying phenomenon, and usually it was a stationary ether with respect to a rotating Earth, because that's, they all believed in heliocentrism and all that. But it's just a framework to interpret the phenomenon, right? So these are actual effects that are happening, and it's like, well, how do we explain the effects, that are going on? And the reason that they have an ether, right? The reason that there's a variance to see is that the ether is what is facilitating that mechanism.
Dude, that's a really good way to put it. They're observing this phenomenon, but they're observing it from the framework of a moving Earth and a stationary ether. And we can interpret the same phenomenon from the framework of a stationary Earth and a moving ether. So that's the trick that they've been playing the whole time.
Exactly. And it's not even necessarily a trick, because, people believe in it, and, they turn on the TV and they see people walking on the moon and they're like, oh yeah, of course, so it's obviously they're going to interpret it always through like the heliocentric paradigm, in that regard. So a lot of the stuff that you'll read, will be kind of placated towards interpreting it towards these like quote unquote galactic speeds and all that. But that's just for them, right, to justify their that's just for them, you know what I mean? Like, it's just a little thing for them to play around with, and with the math. That's just their lens of looking at it.
I like the analogy of like you're trying to solve a puzzle when you're looking into the Michelson-Morley and the historicity of the interferometry experiments. You're trying to solve a puzzle, but you're upside down when you're solving this puzzle, because you're looking at it from an opposing inverse framework of interpretation. So you got to remember when you're done solving the puzzle to stand the fuck up so that everything makes sense, right? Otherwise, you're end up with this heliocentric tilt.
Yeah, absolutely, man, absolutely.
Yeah, showing the hypothesis like this is such a really good illustration of how we literally went backwards of what the theory should be. Like, the hypothesis was we have the opposite of what was hypothesized.
Right, dude. It's crazy, because when you understand that, like, special relativity is a series of second order effects based on presuppositions that aren't true in nature. And it's like, it's just an overlay of the natural world trying to explain it through through a way to ignore the very mechanism that's causing, that would be used to establish the cause and effect relationship to all phenomenon, right? It's like the ultimate way to hide it is like, because once you have people adopt that framework, well, then anytime C varies, they're just going to change the coordinate system with second order corrections, and
Third, fourth, fifth. Why not?
yeah, and that's why they don't even talk about the geocentric implications of it and the implications of the Earth being stationary in these experiments. Like you'll find a couple of quotes here and there, but like the primary logical, conclusion is like if there's slight fringes, then we're stationary with respect to an ether wind, and that's really all there is to it. To the way that they tried to, or the way that they did this was so backwards and antithetical to science. I can see why people look at this experiment and they don't know what to make of it. They're like, is it an experiment? Is it a demonstration? Did they lie? Did they just make the whole thing? Did they just make the whole thing up? Because when you look at something like the Arthur Eddington experiment, well, there weren't even any stars to be displaced at the solar limb. So like, yeah, they just made that entire thing up. So like, is this another case of this? And it's like, well, no, let's thoroughly re-examine the history of what was going on and why these people had these frameworks and why they thought what they thought and why they were doing this experiment and what it meant to them, and why everything had to change moving forward after they got results that didn't agree with heliocentrism.
Real quick before you change the slide, you guys probably have it figured out, but I was just watching that.
You sound
YouTube
like
for a
shit,
second.
Dave.
I know, I probably do. Can you hear me at all though?
Yeah, you're good, bro. Continue. What's up?
Okay. Yeah, I was having an audio issue, so I was watching on YouTube, and it's going out at like 144. You can't read this slide at all if you're watching on the YouTube stream. I don't know if there's anything you can do for adjusting like the output to YouTube at a higher res
What?
or if that matters.
There's nothing that could be done at the moment, but I have a recording of it. I'll upload it later, and it'll be in full quality, so it's fine.
Okay, cool.
Also, the Æther Cosmology stream is looking good, I think.
Is it really on quality, or is he just on his phone again?
And then also on the quality.
Yeah, like I say, it looks okay.
Yeah. Okay. Cool. So
if you watch it there, it'll be good quality.
Okay.
Well,
Cool.
and Æther Cosmology is where I was watching it, and it was like low res, at least for me. Maybe
Oh,
really?
Yeah, that's what I was saying.
No, I get 1440p, 60 FPS. Keep going.
Yeah, it's looking good.
Okay,
For
never
me.
mind.
All right.
It must
Cool.
just be my phone.
All right. Tight. So we'll go ahead and continue here. So this is the Michelson-Morley apparatus. This is the device that Albert Michelson and Edward Morley came up with to use. Now, the first experiment that Michelson did in 1881, they used a device that was a little less robust, and it was overly sensitive to what they needed. So like they don't really talk too much about that experiment in terms of like the proof or whatever. So like they use the 1887 one as like the jumping off point. So what you're looking at here is the modified version of what they ran with before. So the big difference here is this is in a mercury vat floating on wood, so it's like perfectly level, and there's less vibration and disturbance, from environmental, factors like cars and trucks and stuff going by and all that. So what they did here is they have a coherent light beam, they have a beam splitter, they have reflective mirrors, and they added more reflective mirrors to increase the size of the fringe so that they could read it better. So what these mirrors do is they're just basically adding more length to what's needed for the light to travel. So they're just increasing the effect that the ether has had, like that they're measuring, they're just allowing it to take a larger measurement. So what they could do with this device and its mercury vat is they could rotate it and then let it rest, and it would, be perfectly at rest and aligned how they would need to have it aligned to be in such that one of the arms would be perpendicular to the direction of Earth's motion. And this is what they were going to use to measure the variance in the speed of light in Earth's motion through the ether, right? Or they were going to measure the stationariness of Earth with respect to an ether wind. Either one could go either one. Let's see what happens or whatever. So in terms of experimental variables, so we got like independent, controlled, dependent, and all that. So we're going to go over that real quick and talk about what those are and how they relate to the Michelson-Morley experiment. So for the independent, we have the orientation of the interferometer with respect to the direction of Earth's orbit. The apparatus was aligned in such a way that an arm would be perpendicular to the direction of motion, and it will experience resistance to a stationary ether, causing a variance in C, which will produce a fringe shift pattern. Changing the orientation of the apparatus and observing the fringes will allow us to interpret and establish a cause and effect relationship with what's causing the fringe shift pattern. Is it the orbit? Is it just a random thing? Is it happening? Is it an effect happening outside of the confines of the assumption of the orbit? So that's what that would be the independent variable for heliocentrism, right? The direction of orbit. And this is how you would verify that, right? So the working assumption is that's true. So we're aligning the interferometers in such a way that a stationary ether would, create ether drag, and there would be a variance in C, which we could use to measure the Earth's orbital velocity, right? So interpretations of the result regarding the hypothesis detecting Earth's motion: 5 fringes, each fringe corresponding to 5 kilometers, would provide positive evidence for heliocentrism. No fringe or a slight reading. C is invariant with respect to the source or observer in combination with special relativity, which is second order effects. That could be used to formulate a theory to explain it, and that could be used for positive evidence for heliocentrism if you're down with believing in second order corrections. Slight fringe. The Earth is stationary with respect to an ether wind. Positive evidence against heliocentrism. Okay. So experimental variables. The dependent variable is going to be the fringe shift pattern that is produced based on the variance of the fringe is either going to be produced by Earth's motion or a stationary Earth with respect to an ether wind, and the strength of the reading will help us interpret that. And of course, isolating the other control variables such as temperature, heat, altitude, all that sort of stuff. The materials used in the interferometer, changing locations, all that sort of stuff. That will help narrow down and establish that cause and effect relationship with the independent variable, which is again trying to establish: is it Earth's orbit around the sun, or is it a stationary Earth with respect to an ether wind, with respect to the universe rotating around us, right? All right. So the controlled on these experiments would be the vibration of the apparatus. So accounting for that by putting it in mercury so that it floats evenly and level, and increasing the mirrors so that the speed, or so that the distance that light has to travel is increased so that the effects are easier to read. And then taking the readings at different times of day and keeping the device orientated, with respect to Earth's assumed orbit, so that you can isolate it. Like, is the Earth rotating into the orbit? Is it rotating out? Is Earth's rotation affecting it in any sort of way? So they took the readings at different times of the day to help establish that as well. So this is a topographical view of what the paths of the light beams looks like after it hits all the reflectors and beam splitters and hits back and then hits the photographic plate and all that. So that's just that's what that looks like. So these are the results that they got. So these are your 2 different readings, or these are your 2 different times a day that these readings were taken here. And the dotted line is the projected amount that they predicted for heliocentrism, right? And the lower amount is for geocentrism. I'm just saying that this is for, they didn't say this in the paper. I'm saying this. This would be positive evidence for a stationary Earth with respect to an ether wind. So if there's a, slight fringe, or a fringe that's over, over one fringe, it's over the air tolerance, but it's not, some crazy high number where it's like, oh, okay, maybe it is, maybe we are moving or whatever, right? So again, this is the total results for both times as well, or for both time periods. So again, the predicted results, they needed that 5th fringe. They got just over 1 fringe. So their interpretation was that it was between 5.5 and 6 to 7 kilometers a second. So step 5 of the steps that we laid out earlier, conclusion and deriving a theory. The experimental results of the fringe produced was 1/6 to 1/8 of that required for a positive first order measurement of Earth's orbital velocity. Theory 1, heliocentrism, attributing the slight fringe to air, attributing the fringe to instrumental air. Postulates based on the invariance of C regarding the source and observer can later be used as a mathematical framework to reinterpret the experimental results with, i.e., the Lorentz Æther framework, and later renamed special relativity through second order corrections, time dilation, and length contraction. With under this new framework of the assumed invariance of C, the slight fringe produced in the experiment is produced by the mechanism of space-time contracting the apparatus slightly so that it doesn't give a full 30 kilometers a second reading. It gives a 5 kilometers a second reading. So that's the explanation, or that's the Steelman of the interpretation that they went forward based on the results. So note, in special relativity, an observer outside of Earth's reference frame would not see a fringe pattern if they could observe the Michelson-Morley experiment being conducted on Earth. So if you had like a magic telescope and you were on the reference frame of the sun and you were looking at people doing the Michelson-Morley experiment and you could see the fringe pattern from there, you wouldn't see any fringe pattern. It would be because the speed of light is the same, that you wouldn't experience the length contraction that we're experiencing. But from our reference frame, we measure a slight fringe. So that's the interpretation that they went with there.
Like having like a mathematical imagination.
Yeah.
So we can mathematically imagine it. So there you go.
More accurately, a mathematical coordinate system with a specific set of metric tensions that I can fit to literally any physically plausible information to make my model work.
Absolutely. Well said. So another interpretation though. So step 5, conclusions and deriving the theory. So remember, we can interpret, this data ourselves, right? Like this is just an interpretation, right? It doesn't, just because they interpret it one way doesn't mean we have to. So another way that you could interpret this experimental data without second order corrections or postulates is the Earth is stationary with respect to an ether wind that follows the sidereal rotation of the sky. Note that there are no second order corrections required, i.e. length contraction or time dilation, or special postulates that are required for the interpretation. Normally, first order measurements corresponding to the viable hypothesis are the favored interpretation, as this is the highest form of experimental evidence that can be provided for a theory or hypothesis.
So normally people would accept this and not make up branches of physics to explain and interpret shit that doesn't fit their model. Man, that's so good.
Yep. So normally that's how things would go, but they ended up discovering that actually space and time are intertwined and they converge and diverge hyperbolically.
near infinite on a line.
Yeah, to meet C. So that's what they went with. So anyway, so here we go with replication. So in terms of so that last part of the step, that last process was replication, right? So the important process of the scientific method is replication. How can these experiments be replicated? Can we show a variance in C? Can we show evidence for an ether? Can we show evidence for space-time? Is there evidence for geocentrism? Is there evidence to support our interpretation of Michelson-Morley, or does it all favor space-time now? Well, let's look at the experimental evidence since Michelson-Morley. So starting with Michelson-Morley here, 1887, on the relative motion of Earth in the luminiferous ether. That was 1887. And then in 1993, we have George Sagnac, who came through with the existence of the luminiferous ether demonstrated by means of the effect of relative ether wind on a uniformly rotating interferometer. So what he did is instead of aligning a device perpendicular, to the direction of Earth's motion and all that, all he did was just have a device that was constantly rotating at a fixed amount, and that rotation produced a fringe shift pattern, and through that they there's an example of uh of the speed of light varying, right? So they said in special relativity that because the device is rotating, it's a non-inertial reference frame, and therefore special relativity doesn't apply, even though they have other ways of deriving circular effects in special relativity. For this one, there was a big no-no. They decided that they couldn't do it for some reason. So anyway, while they were struggling to come up with that until 1918, it wasn't until 1918 through the general theory that they were able to explain the Sagnac effect using metric tensors specially placated to describe the conservation laws on the small scale, so that they could say that the rotating interferometer was producing pockets of time dilation and length contraction, and link that through linked by the equivalence principle. Um, and all that. So that's how they ended up scooping up the Sagnac effect. But shortly after that, the Michelson and Gale and some other guy got together in 1925, and the Earth's rotation and the effect of that on the velocity of light. So what they did is they just built a big rectangular interferometer, which we'll get into. Actually, kind of reading ahead of all these. I'm going to show you the graphics for all these as we're going to go through them and not just talk about them. So I apologize, got a little carried away. We'll just continue on as if I did this properly. So recapping on the Michelson-Morley, they had their predicted fringe amount and the amount that they actually got for both readings. And this is just recapping on the control variables. So this is where they were accounting for the vibrations, the mercury pool, and all that, and taking the readings at different times and all that stuff. So second, we have the Sagnac effect. So this is the rotating interferometer that I was talking about earlier. And what he found was that there is a fringe shift pattern produced by the rotating interferometer. And of course, this, relativity didn't want anything to do with this until they could explain it later with the general theory. And then while all that was happening, Michelson-Gale came along in 1925, and they built a giant rectangular interferometer. So same exact concept here. So light enters here, splits, hits these reflective mirrors, bounces back, recombines, hits a photographic plate, and you get a fringe shift pattern. And what they found is that relative to the latitude, there's a fringe shift that matches the sidereal rotation. So similar to how they say on the globe, you're rotating 1,000 miles an hour at the equator. Well, at the where was this done? I think this one was near Cleveland, I think, or somewhere near, or maybe it was Chicago. But anyway, relative to that latitude or whatever, the fringe shift pattern corresponded to what would be like about 750 miles per hour if you were going to get the translational speed. So it was like roughly matching that for the interpretation of the what's it called, of the sidereal time, and that's with no relativistic corrections or anything, using a framework that explicitly measures relative motion against a fixed background. So using a fixed Æther framework, and that's just the how they're like mathematically describing it, right? So what they did for the equation there is they're just comparing the relative speed of the light that went from traveling in the north south poles and the east west poles, and that's where they're got their fringe shift pattern and all that. And then we have Dayton Miller, who continued the Michelson-Morley experiments from 1905 to 1925 and published two publications on his work, one in 1925 and a final summary with additional corrections and reinterpretations on in 1930, where what he was measuring is so someone's echoing. If you could settle that for, actually, I got it.
Oh yeah.
So what he was measuring was during the equinoxes, the sun has to move at a certain speed. Now, in the heliocentric model, this is where they would be saying on the elliptical orbit, the sun is slowing down and speeding up. Yeah, so
Everyone keeps trying to mute him.
Yeah, just so this is where they're saying the sun is slowing down and speeding up. So this is what Dayton Miller was measuring. Now, the way that he was measuring it, though, the way that special relativity came into effect, they said that Dayton Miller couldn't be measuring these because this is under an etheric framework and heliocentrism under the mechanisms and the framework of which they were taking everything. They they had no way to explain this, so they ignored these experiments. But what Dayton Miller measured was a speed fluctuation change in the ether relative to the sun, as it would have to change speeds in the northern hemisphere and the southern hemisphere to maintain the 15 degrees per hour. So on a flat Earth, like you know how we get the analemma and all that because the southern hemisphere is clearly bigger, and but the sun has to move at the same speed because we get the 15 degrees per hour, right? So that translational speed to keep up with that fluctuation is what Dayton Miller measured to the day with interferometry, where the fringe shift patterns reach their minimum and maximum dimensions on the day of the equinoxes. Um, that was through 5,200,000 experiments. And what he was doing primarily is he would do a set of experiments, and then he would get critiques and feedback, and he would do all the control variables, address all the critiques, and just keep doing more and more experiments. And this is the summation of all the data that he collected. When you plot it against sidereal time, there's a direct cause and effect relationship with what he's measuring with the translation of motion of the sky. When you plot it against diurnal seasonal time, i.e., daily temperature effects, there's no cause and effect relationship with the fringe shift patterns produced. And so, and even Einstein acknowledged that if Dayton Miller's work were to be reproduced, then general theory and the special theory gets game over. There's no way to interpret it through relativistic means. It would be a direct contradiction to his theory and all that stuff. And we're going to look at some people that actually reproduce Dayton Miller's work and provide positive evidence for the etheric framework. So before we get into those people, we're going to get into DeFore and Pruner. So these two gentlemen, the Sagnac device was the circular interferometer that was rotating, right? And they special relativity said, well, because the device is rotating, we don't care, right? Well, this guy just made a circular interferometer and he didn't rotate it. And he produced the same effects that were shown in Michelson-Morley. He produced the same effects that were shown in Sagnac and Michelson-Gale. So this same variance in speed of light was shown, and there was no mechanism to explain it because this time it was just the device was a circle and it wasn't rotating. So, it was an inertial frame, and there was no way to explain it. And that was done in 1942. And even the guy, Paul Lavue, who came up with the special metric to answer the Sagnac effect, couldn't answer this because basically what happened was, so special relativity could describe any location on a rotating disk except for being at the center of it. In this case, because it was stationary and how it would affect or how they would calculate the motion. So it actually, so when they're like, oh, all reference frames are equally valid and all that stuff, well, it gets contradicted in that regard on this through the math, and they go over that here in the paper. And so in 2002, we have a replication of Dayton Miller. So remember back to the legend that was measuring the sidereal rotation of the sky and a fluctuation of the ether relative to the equinox to the day. So this effect was reproduced with optical bands and with radio millimeter waves. So two different apparatuses, two different wavelengths, two different types of electromagnetic propagation, and the effect still persist, and it still reaches its minimum and maximum dimensions on the equinoxes to the day. And here's the data for the other one that the same guy did.
Do you mean on the equinox or on the solstices?
What's that?
Do you mean that? So, like, did he measure the max and min to correspond with the two solstices or the one equinox for the year? Right.
Yeah, the two solstices. Sorry. So Yuri Galev, same thing. Or, I'm sorry. Yeah, that was so Galev. This was his second experiment, following the same thing. Got the same readings, and This is 2004. This is the generalized Sagnac effect. So this is a pivotal moment in history. Actually, this I think should be one of the, so similarly to how the Michelson-Morley was one of the biggest experiments in physics, because it was a big moment where it was like all these theories came to a head, right? All like they finally had a way to measure these and figure things out, and it was all hinging on the interpretations of these experiments. So the way that they co-opted the experiments, I'm sorry, the way that they explained the Sagnac effect, the rotation, is that they said that this effect is explicitly due to rotation. This is a rotational effect, and they say that that it's in fact the Earth's rotation that's producing this effect. So when you hear an inertial guidance system detects 15 degrees per hour, and you hear thanks Bob and all these things and the 15 degrees per hour, that's what they're saying is corresponding to this. That's what they're reading, and that's what they're saying the Sagnac effect is produced from the Earth's rotation, and that's producing a fringe shift pattern that's corresponding to that. So in 2004, a guy named Ruyong Wang did an experiment with a fiber optic cable where he turned it into he made a conveyor belt of it basically, and he showed that the linear bits also contribute to the fringe shift pattern in addition to their rotation bits. So what that means is that the Sagnac effect is not due to it's not due to just rotation. It's not a rotational effect. He actually, the way that he did this experiment and doing it in different directions, he showed that the effect is actually depends on which direction you're facing. So the effects persist in the east and west when the propagation is going in those directions. So it's faster going east and it's slower going west or west to east than it is going from east to west. So that's a direct contradiction to how they try to explain the effect in the heliocentric model, to where they say that these devices, these inertial navigation systems, these thanks Bob devices, no longer have they're no longer evidence for the rotation of the globe. They're no longer evidence for that. Right. And then it further brings into question that interferometry being able to measure linear motion. So one of the ways that they got out of the Michelson-Morley experiment is they say that that device wasn't able to measure linear motion, but somehow but somehow the Michelson-Gale device was. But in the rotating interferometer through the Sagnac effect is able to measure it. But in terms of Earth's orbital velocity, the Michelson-Morley device couldn't do that. So this proves that it could absolutely detect linear motion, and that Earth's orbital velocity should have got the full reading, and that there is an Æther effect. And if there is a variance in speed, the delay in which will be reflected in the fringe shift relative to how fast you're moving. So if the Earth were truly in motion at 30 kilometers a second, all of that would be detectable by interferometry and later in GPS, which I think we're about to get into real quick. In the next couple of slides, we'll close out on GPS. We're almost done here. So just to recap, were you saying something, Shane?
I just
Nope.
said funny because I thought it's just funny how they claim the experiments when it's convenient, and then they like say it's linear when they want it to be, and it's not when they don't need it to be or whatever.
Yeah.
Yeah, dude, it's super convenient. All of the ways in which they don't have to detect Earth's orbital velocity.
Yeah, so remember they had to apply second order corrections to the Michelson-Morley experiment to say that the device contracted by X amount to give the full for them to have the full interpretation of the 30 kilometers. Now for the Sagnac effect and for Michelson-Gale, they didn't apply any relativistic corrections, and they were able to derive the corrections using an etheric framework. So like that should kind of tell you all you need to know right there. But to reiterate real quick, so originally the interpretation of the Sagnac effect was derived from the circular equation, which is delta t here, which means the fringe shift pattern produced is going to be equal to 4 times the angular rotation of the area of the device divided by the speed of light squared. So what they're saying here, omega is for when you're talking about something that's rotating, a circular device that's in rotation, and A is just the area of the device, meaning that the length that the path length that light has to travel in the device. So if you're using a fiber optic cable that's 100 meters and you have it in a spool or whatever, your area is going to be 100 meters. If you have it on a reflective mirrors or whatever, it's going to be whatever the distance is of those mirrors is. So it's going to be that entire length of propagation. So for the linear effect that Wang did in his experiment and the equation that he used for delta t, so the amount of fringe shift produced is going to be 2 times the velocity times the length of the device. So the length that the again, just the area that the path has to travel, right? So in the case of a 100-foot cable, it's going to be 100 foot again, same exact thing. The velocity this time just being the speed of motion. So instead of being rotational effects, the rotational speed, it's just the regular translational speed, and it's going to be 2 times that, and then divided by c. So using this equation, he actually derives the circular effect from it as well. Or he derives the circular prediction as well using that. So he shows that these are mathematically equivalent in that regard, and that this, so the effect isn't explicitly due to rotation. Isn't
So the
explicitly
circular measurements are a result of the actual linear motion.
Yep,
the-
exactly.
There you go. That's a good way to put it.
Exactly. That's the key takeaway, right? And this is all facilitated by the mechanism of the Æther, right? So when they talk about an absolute reference frame, so they're talking about 2 things. One, mathematically speaking, this is a stationary frame that you could say is at rest, that you could measure relative motion against. So that's how you could use the frame mathematically. And then in terms of the effect, you're going to be it's going to be your motion relative to the Æther. That's what's going to affect the electromagnetic propagation, right? The speed of light isn't relative to you. It's going to be interpreted through your speed relative to the Æther, because that's the only way to facilitate that mechanism. That's exactly how it works, and that's what's later shown in GPS, like explicitly how it works with the range measurement equation, and when it gets into accurately predicting distances for moving objects and stuff, and how the delay is proportional to the velocity of the observer. Like that's explicitly due to the mechanism is the observer is relative to the Æther, and that's why the speed of propagation is changing relative to that's how it's changing relative to meet the observer. Does that make sense?
Yeah.
Like it's not like light just all of a sudden is like, oh, I gotta slow down or speed up a little bit to catch up to this guy. Like it's all relative through the Æther.
Or even worse, that time and space are going to dilate.
Yeah.
Get there on time or whatever. Yeah.
Exactly. Okay. So to wrap up here, so Hector Manera in 2006 using a classic Michelson-Morley interferometer. So just your standard arms, north-south, no rotation, nothing fancy, nothing like that. And the way that these gentlemen did their experiment was they left the device running for 3 years. So they took 3 consistent years of measurements, and wouldn't you know, on the equinoxes, the fluctuation speed is measured, replicating Dayton Miller again for the 3rd time.
Nice.
Wait, who was this?
So this is Hector Manera in 2006.
And that was with sorry, you just said okay, Michelson interferometer. Got it. Cool.
Yeah.
Dude, it's from the observation during 2004, the periodic fringe shifts, and then, oh boy,
Yeah. So
ADIL epiteleometric stationary Michelson-Morley experiment. Man, that's a word.
Yeah, so the adipial polymetometric thing, what that word means is constantly running and not ending. So they left the
Nice.
device running for 3 years straight.
Couldn't they have just said perpetual or something? Like whatever.
But then they couldn't have combined Greek and Latin words, because they actually go in, like the whole beginning part of their paper is like, hey, we got to make up this nice cool word. And
Really?
so Yeah, so you can find out more about that on their paper there. But yeah, so they replicated Dayton Miller once again, showing that there is an ether and the ether framework is valid, and that there's even less reason to interpret the Michelson-Morley through the second order corrections brought to you by Einstein in the form of length contraction and time dilation. All right. So to close out real quick on GPS, another thing that Wang points out here is that, like I was saying earlier, with the speed of light being delayed relative or proportionally to the velocity of the observer, and this is being shown through the accuracy in GPS, um, the mechanism for that is the ether. Your motion is relative to the ether, and that is what is causing the variance in the speed of light to the observer, which they explicitly say is not happening in special relativity. So, just to close out here, contrary to the appearance of the range measurement equation that the speed of the receiver v does not appear explicitly, the speed of the receiver is implied in the definition of the position of the receiver, i.e., the position of the receiver at reception time. So this was going into to how the range measurement equation works and how it's a time interval system, and how it doesn't, on the surface level, it doesn't look like they're altering the speed of light, but they actually are, and that's reflected in the accuracy of the time interval system that's used based on the location at reception time, and that reception time is what they're subtracting to show the difference in c from the propagation from when the time was sent. So compared with the position of the stationary receiver at reception time, the position of the moving receiver at the reception time is different, and the difference is proportional to the speed of the moving receiver v, so his velocity. So, and again, a quick recap on the demonstration was a stationary and or moving GPS satellite or whatever, right, sends a signal out to a stationary and a moving receiver. At the same instance that the moving receiver intersects with the stationary receiver, the they should, if Einstein's theory is true and all that, these two gentlemen should receive the signal at the same time, but they don't. Gentlemen, the moving receiver receives the signal delayed proportionally to how fast he's traveling, and that is all hands down first order effects of the ether. That is exactly what you would expect and predict with an ether framework, because all motion would be relative to the ether, and this is how you would like utilize technology and mathematically to use measurements of that motion relative to the ether to get accurate coordinate measurements. So that's it. And I was going to close out on Ron Hatch reiterating everything I just said, but I think I recapped it enough. I don't think anyone wants to hear it again. So I think we're good on that. So with that being said, I want to close out and say that, you know, if you're not into the ether framework, if you don't think it's scientific enough, that's okay. At the end of the day, we all believe in different things, and that's okay. But that's my case for putting forward that Michelson-Morley is an experiment, and the ether framework is experimentally valid, and that there is positive evidence for it. There's repeatable effects, and there's technology that's utilized explicitly on these etheric effects, meaning the speed, the relative motion to the ether is being measured, and that's providing accurate measurements in GPS. Like, you know, like there's no for me, there's no way to ignore the ether, you know, in that regard. Like it seems like there's sufficient evidence experimentally, philosophically, you know, to move forward with that. So so that's the end of my presentation on that. I hope you guys enjoyed it. Thank you for stopping by. If anyone has any questions, happy to answer.
No questions off the top of my head, but man, thank you. Like that was fantastic. That was like my favorite one yet.
Right, this is so good. This just nails it home. You gotta like, so everyone has been measuring motion since the beginning of people taking measurements, right? You can interpret it in the two basic frameworks, which are inversions of each other. You can have uh, a, a moving Earth and a stationary ether, or a stationary Earth and a moving ether. And there is no other camp. So other people who don't believe in an ether framework, I don't understand how they interpret the results of these, say, 5,200,000 Dayton Miller interferometry experiments, clearly measuring a motion and a difference in motion of some fucking kind. So the only way you can deal with this is you can interpret it in one of the given frameworks. Otherwise, you're an actual science denier, I guess is what I'm saying.
Yeah, it's quite taking the opposite position on it or whatever, really inverts it in that way where it makes you like anti-science, like in the way that you just described. Because, like I said, the previous framework of interpretation was the ether. Now, obviously, they had different frameworks and they were trying to explain different phenomenon, and obviously through the lens of heliocentrism. So they were trying to put it through the Earth's motion, to get everything through it. So there's obviously going to be, some incorrectness and biases and things in there that don't make sense, but the effects, are real, but they had to, to avoid any discrepancies and have like a monopoly, so to speak. They had to go with the Einstein framework because it provided an explanation to all these, uh, like it provided an explanation to what we're seeing, like the mechanisms, like the effects, without having to describe or acknowledge the actual mechanism itself. And you could just say the abstract math is responsible for it.
That abstract math get out of jail card. They use it a lot.
Yeah. And that was a big part of why they had to rush in the general theory, because the special theory was failing so hard with all these interferometry experiments. And they had to merge it quick. That's why Einstein was like, yeah, general principle, tensor calculus, roll it out. It's all the same. It's like, is it though? And it's like, well, it's like someone needed it to be, because without it, they couldn't explain these effects and the lack of Earth's motion, because sooner or later, someone was going to come along like Wang and do an experiment that was going to just completely refute everything.
Yeah.
What Wang did in 2004, that moment where everyone's like, why doesn't he have a Nobel Prize? Wouldn't you win $1 million if you disproved Einstein? Ha ha ha. Like that already happened in 2004 from Ruyong Wang, and not a single person can acknowledge it because of the implications of what it actually means and what he actually showed, where the effect is with respect to a stationary Earth, like the ether wind is with respect to a stationary Earth, because the way it works with the conveyor belt and the motion of it and the directions in which he was orientating the devices, he was isolating, like, is this an effect due to Earth's motion or, assumed rotation and all that? And no, it's directionally dependent and it's with respect to a stationary Earth. So there's not a lot of wiggle room experimentally in to not acknowledge that and like move forward and like use these as the argumentations. Like we're losing a lot of ground, uh where we don't have to in the actual scientific realm, like, where things are like actually at that level of like experiment and replication and all that. It's like we just have to start talking about it more, bringing it forward, because everything's already been done. Like we have all the experiments, we have people repeating the experiments, we have a whole collage of experimental results of replicating the variance in the speed of light and showing that there's no orbital velocity. And if there's no orbital velocity, then the axioms upon which heliocentrism rests are not true, directly, observably, and measurably in nature. So there's
We can't.
yeah. So it's like, that's a wrap, these are, so yeah, I hope this helps bring in, or like, interest people in the experiment, because it is, like I said, or I think Shane said, it's a real barrel of snakes to try and figure out what went on here, because of what they had to do and what they had to hide, because of the implications are so profound. It's so one-sided once you understand it, and there's no way for them to argue against it.
I got a
Right.
I got a $1 zillion question. Alan.
What's up?
Okay. In the interferometry, okay, if they know which path that the lasers, whatever, the photons are taking, how are they getting an interference pattern? Ain't that supposed to collapse the interference pattern, right? So just want to throw that out there. They forced a path that's supposed to collapse the interference pattern and the wave function.
Mixing up experiments, Brian.
Figured I'd throw that out there. That right there, that knowing what path light goes doesn't mean shit about anything. It's not a independent variable, right?
What? No, let's just. I thought you nailed it home when you reiterated that Earth's orbital velocity has never been measured. Like when we went over Dayton Miller, who took 5,200,000 measurements, not all of them being sensitive enough to measure Earth's orbital velocity, none of them detecting any measurement. The only thing that we've ever quibbled over is these varying it was the interpretation of the measurements of motion of some kind. And like I said before, from the framework of either a stationary Earth and a rotating ether, which is our framework, or from the heliocentric framework from a rotating Earth and a stationary ether. Those are the only two possible ways to interpret all of these experiments and all of the results. So people who go outside of that and say that it's not science, or like they choose to not interpret this motion at all, like I don't know what those people would say.
It's top-notch science, dude. It's fucking ridiculous. But dude, that's what Toon tried to when I talked to him for the first time. And I brought up Michelson-Morley. It's probably about 5 years ago, 4 years ago, and he tried to tell me that they do measure the orbit around the sun. He's like, they measure the daily rotation and the orbit around the sun. He's just saying anything, dude. Back then, ridiculous. But I didn't have this artillery. You know what I'm saying? I knew it was horse shit. I knew he couldn't, prove it, but it was his channel and everything. I wish I had the artillery back then, but at least we have it now. Good work, Alan.
Thank you, sir.
Yeah, man. That is a linchpin, dude. The Earth's orbital velocity. I can't believe anyone would have the balls to say on the internet that, yeah, we've measured Earth's orbital velocity at 66,600 miles around the Earth. Yeah, we've definitely measured it because nobody ever has and nobody ever will.
Experiment. What I was trying to tell him when I went on that subject is that the hypothesis would basically be. I mean, you could form a few hypotheses really, but just one of them being you could form it for any of the experiments. The stars moving, and what's causing it? Is it the ground moving or is it the sky moving? And then QE freaked out on me. You can't manipulate the ground. I'm like, yeah, the fuck I can, dude. Like, dude, I could move my instrument. And on the ground, I mean, what are you talking about? I could put it on a conveyor belt. I could put it on a track. I mean, I ain't talking about moving the whole damn Earth, dude. I'm just, But anyway, to me, yeah, we could easily formulate a hypothesis. But I mean, that was the hypothesis for Aries failure, right? Whether it was the telescope moving or the stars. And but yeah, that's definitely, bro. People who claim it ain't science, I don't buy it. I'm gonna defend you every time.
Yo, I see Cyrus is here, but he wasn't here for any of the stuff that he should have listened to, I think, so that he can agree with us.
Oh, that's okay. I got you. Yo, Cyrus, do you agree that differential equations describe the ether when they're talking about electricity? Yes, I agree. All right, cool. We're all in agreement.
Cyrus might be here only in spirit for the moment.
Yeah, that sounds like something
I mean, how
Cyrus
do
would
you?
agree with.
Yeah, I'm still puzzled by how you can have charge, like without matter, basically. I mean, without something. I'm having a hard pass that one out.
Well, you
To me,
can't.
that's
That's why Maxwell just mathematically said that, and then like there's no experiment to verify that. Like that's why, like you know, it's a real stopper or like brain stumper or whatever. But the only explanation is that there exists a mathematical explanation. Is that some
Yo, we
guy
got
said
a
it
short
doesn't
for
have
that.
to?
Yo, we got YouTube shorts for everything now.
Yeah, dude, you've been crushing making those
Oh
shorts
yeah,
with those awesome clips, man. You're awesome.
yeah. What
You
carries
guys
charge
make it easy,
potential?
man.
Nice.
who's that? I want to see. I want to put me in, coach. Who's making shorts?
Toby, the guy we all just publicly congratulated, Leaky.
God, sure, because you were just talking about Cyrus.
Yeah,
Yeah, I
I said
didn't.
Toby.
If there's a pause, if you guys can hear me, if there's a
Yeah.
pause in the action here, you could actually play some of those YouTube shorts for anybody listening.
Don't play shit. Fuck that. I didn't come here to listen to other people's videos, bro. I can just disconnect and watch videos.
Oh
on
no,
my
we
own.
were trying to talk to you.
Yeah, you guys.
Oh, yeah,
you
so
guys
he's right.
addressed me. You guys addressed me while I was upstairs and my phone was downstairs. Like you picked the right moment to not address me, bro. So
What,
Did you come
like
to that-
if I wanted to talk shit, that was the best time, you mean?
that is. Yes.
Did you get
my
here 'cause I
answer
gave
to
you the
that.
heads up?
Yes. Yes to Alan. What? What's that new perspective?
No,
I
she
just
was
asked,
listening.
Did you get here because I just gave you the heads up?
Yeah. Because you sent me the
Okay,
link.
good.
Yeah. I was like, oh, okay, cool.
Good
Convo
job,
solved
new
then.
perspective.
He knows how it works.
Nice. Yo,
You
Edward.
gotta be
Edward,
like, oh, hey, over here. It's like, okay, cool.
did you catch that presentation, and/or did you have any questions?
I did not catch the presentation, and I agreed to your question. I said yes.
Nice.
That's what it describes. Yes, the ether, exactly. And yes, you can have charge without matter. Yeah, that's that shit that we're dealing with here, bro. Yes, it's called electricity. It's not. It does not have a physical nature. It does not have mass. That's why it's not in the realm of study for physics, because physics deals with physical materials. Electricity is not physical, so it's not a study of physics. It's metaphysics. It's beyond physical. So that's the issue here. And in physics, right, you got the SI units. You have to, if you can't assign grams to it, you have issues, right? In physics in general. So
I don't like saying mass, man. That to me is kind of like a trick word. I'm saying without.
okay, just take it colloquially, bro, as the amount of stuff.
There are no
Yeah.
trick words,
you know,
man.
Yeah,
come
let's
on.
just go with the classical mass equals the weight, no relativistic
Yeah.
corrections involved. But before we move on, Edward, did you have anything you wanted to ask about?
I actually just came in like 2 minutes ago, so I missed. I was going to Rumble actually to look at something, and I saw where it showed Shane was live, or this was live. I think it was on his channel. So I've got to go back and do some watching and catch up with y'all on it tomorrow. What was the main topic, or did it center around something?
The
Yeah.
scientific background of the ether. Yeah.
Yeah, history of the Æther,
Maxwell?
Michelson-Morley experiment, that kind
Yeah,
of
the
stuff.
historicity of the scientific experiments that validate the ether.
I watched some stolen history. There were a couple of them that were about 2 hours long, and one of them centered on the World Fairs a bunch. But and then
Yeah,
I
that's one
found
of my
some
favorites, to be honest.
man, and I think it actually, so that just the way it really talked about how history could have been revised and possibly has been. I know we're all kind of shooting in the dark, but these guys, they're called something like Templar or something. It's weird because they're into everything like Tartaria, ether, everything except flat Earth, which they're vehemently against, which I found was funny. But I remember what it was like to not be able to, like, I was open to everything but that.
Dude,
But,
globular etherists? What the hell is that?
That's it, like, brother,
Oh,
they can't give up
exist,
the
bro.
space stories. They can't,
They
like,
exist.
no, don't tell me rockets aren't real.
Wow.
Yeah. I'll try and find the channel I know it's on BitChute. I'm not sure if they're anywhere else. It sounds
Well, then
similar to our, like, the ADL room. If you kind of like this though, like you can tell there's a few of them and they're giving presentations and doing it all. So it's interesting though, whenever because they had one about flat Earth cosmology. I was like, oh, I wonder what they've got to add to the conversation. It was just like
Classic hit
this
piece.
is the most anti-scientific bullshit. It's like, bro, you were just talking about cars that were powered by the atmosphere. Like, what is going on now? And how, and you know, like how everything was reset 300 years ago. Like, what the fuck is happening? But it was that one in particular was really interesting though. They had a lot of things Tartaria-ish related that I had not seen before. And you know, a lot sometimes when you're just clicking around on BitChute or something, there's plenty of like recycled stuff. You feel like you've seen bits and pieces. But I'll try and find that one for y'all because that one especially, like a car being talked about in a newspaper, and it just has these two kind of like almost like what you see on the top of the buildings with the steeples and things. Like it just has two of those poking out from the front near where the bumper would be. But and it's like, oh, car powered by the ethereal atmosphere. I did not see this one before. So, but I'll definitely look into this, and I'm sure I will have a question. Probably be able to listen to it tomorrow sometime.
Nice.
Thank you for double checking there, because I'm bound to have some question.
Yeah, dude, that's what's up, bro.
Yeah. Hope y'all are well. Like we were shooting the shit a little bit last night, and then ended up getting a phone call. So it was just like, I don't know, Discord. I wish there was like while you're on the phone, there would be some sort of a, hey, I got a call. Yeah. But that's it's always good hearing y'all catching
They
up.
can always make an ignorant soundboard that says that, and you could press it every time you get a call.
That's it. It's happening.
Well, anyone else have anything Ether related to add, or we can round out the stream? We're at an hour and a half now. I want to make it watchable for people on BitChute. Speaking of BitChute, everything on
Well,
BitChute
Cyrus
is
just
automatically
got
good.
here. Cyrus
He
just
gave me
got here, and all he did was agree with what Alan was asking. Cyrus, do you have anything, since you missed the last one, is there anything else you want to add to the Ether discussion before we round out?
He missed all this one too.
Yeah, I missed everything, so I don't know what to add. Like,
It's weird.
Just
It's a
going over
weird
the
thing to put
Dayton
on the
Miller
spot. Like
I mean,
it was
Ether
pretty
is
much the
awesome.
Dayton Miller and
that's a good addition.
What's your what?
Yeah, it's not my wheelhouse. I'm a JJ Maxwell sort of dude. I'm a electricity ether dude, like sort of. Chemistry, I'm getting into it too, like the etheric side, because those guys back in the days, they resisted the Einstein the most. Actually, like it was so weird. The chemists, they were really the Mendeleev followers, which you know who was? Tesla. He was also a big in Mendeleev's work, and it's very interesting.